In this segment, I want to take a look at hardware devices. I'll look at the objective here, which says describe the impact of infrastructure components in an enterprise network, firewalls, access points, and wireless controllers. I want to look at a couple of other devices as we do that. So hardware devices, hardware is something that we can reach out and touch. We have hardware, software, and middleware, or as we go through these things, BIOSes, for instance, would be those kinds of devices. Okay, the word finally came to me. Firmware. When we do that, firmware, software embedded into the device. So hardware devices are things that we can go to the store and buy, reach out and touch. Hubs and repeaters are two of the devices that we have talked about earlier, and as you recall, they are layer 1 in the OSI model. And we're introducing a different model here, which will be the topic of the next set of lectures, I guess is the word that we're going to use here. So we have this thing called the access layer, the Cisco 3-tier architecture, and this is a Cisco specific thing. So when we look at it, since it is Cisco, it's probably something that you would see again with Cisco. And what we're going to have is a core, which is going to be a high speed. We're going to have layer 3 switches, and then we're going to have a distribution layer, which is we have routers in it, and then we're going to have an access layer, which will have switches, and this is where the users would access the network. Kind of a convenient play on words there, but we would access the network there. As you see, I still can't draw a computer, but the Cisco 3-layer architecture, when we do these things, core would be a backbone arrangement, backbone high speed connectivity. The routers here at the distribution layer, and this might be location 1, and this might be location 2 in our enterprise architecture when we do that. And then in the access layer, we're going to be able to access the internet. We're going to have switches down here and connect that to routers. So the hubs and repeaters are at layer 1 in the OSI layer. And again, we don't want to have these things because when we're talking about a hub, we're talking about a bus, a true bus. What the repeater does, and you notice that the hub has multiple connections that we can put machines on. This has 2. It's going to be like an in and an out. So what we're going to do is to send the signal in, repeat it, and we talked about that. Repeat does not mean amplifier. It's not an amplifier. Regenerates the signal, because as we go on a distance, our signal decreases in any of our media. So, and we have the noise level down here. Before we get to the noise level, we have our 1s and 0s, voltage and no voltage, that can be detected and repeater brought back up to the same level before we again degrade the signal. Hubs and repeaters, we have a true bus here, has collisions, a single collision domain, and that's a big deal when we talk about these things. Collision domains, we're going to have collisions. We talked about that. 2 devices put a signal on the wire at the same time. Then we have a collision. We have to do the random back off and start the whole CSMA CD process over again. The next device that I want to talk about that wasn't in the objective, but we need to know about them anyway, are switches. We have layer 2 switches are located at the access layer of the hierarchy model and the layer 2 of the OSI model. Layer 3 switches are located at the core layer, the backbone layer of the Cisco, the backbone layer of the Cisco hierarchical model. These are the symbols that we'll use in Cisco for those, a layer 2 switch and a layer 3 switch. This is again what one's going to look like. We're going to have multiple ports at the front of it, and switches and hubs look very similar, but this is going to be the number of ports, whatever switch that we have. Provide desktop access to the network at the access layer, and we talked about the core, distribution, and access. When we do that in the access layer, we have the switches, and then the switches have computers or printers or servers, of course server being a computer, but devices connected to it, maybe a wireless access point with tablets, phones, whatever else that we're going to do that. But the access layer is where we access the network. Provide desktop access means for segmenting the LAN into VLANs for larger campuses, and we mentioned VLANs. We will work in VLANs. VLANs is when we break the switch up electrically. We have a bunch of ports here and a bunch of ports here, and we break it up electrically into virtual local area networks, virtual IP networks. VLAN 1, VLAN 2, different IP networks. And to connect these VLANs together, we have to use a router because they become separate broadcast domains. Our special switches that provide several choices of interfaces depending on the type of LAN that we use. Interfaces, whether we have RJ45 or fiber, basically is what we're really talking about there. Maybe token, although token ring is not all that popular anymore. The next thing is routers, and routers are located in the distribution layer of the hierarchical model. If we have the core, distribution, and access. So our switches are going to be connected to our routers in order to be able to go from, if we had multiple local area networks in our single location, and at ECPI that's what we actually did. We broke up each of our rooms into a LAN, a local area network, so that they were each on their own IP subnet, and then we might go from here to a different location. Might go from here just at the distribution layer. We might go to Greensboro, or from Roanoke. We might go from Greensboro or Virginia Beach or Raleigh or Charlotte or wherever else. It's at layer 3 of the OSI model, and this is where IP addressing takes place. And IP addresses can and do change. Remember, the two types of addresses are MAC addresses and IP addresses that we use. The larger the number of WAN connections to the branch and remote offices, the larger the router needed. No real, I think, revelation in that statement, that the more connections, the more traffic we have, the more capable device that we need. Wide variety of routers with varying processor speeds, interface types, densities, memory capacities, and price. Because as we move up into the world, we're going to pay more for them. Share a common interface which makes upgrading easier and more cost effective. Usually the common interfaces we can have, and particularly in WAN, we can have in the middle, we have what's called a DTE, and we'll talk about these, and a DCE to connect two routers together. They may have different connector types at the ends, and this is a serial, and this doesn't have a serial connector on it, but where we bring the two cables together is going to be a common connector, so that we can match the old and the new if we need to do that. So let me get this out of the eraser and into the pointer. Okay, now we're up to the objective stuff, an access point. Access point, a device that provides connection between wireless devices. You probably use one at home, have used one, maybe using one right now. Can be connected to a wired network and can discover and join CAPWAP, controlled and provisioning of wireless access points controller. Controller is going to be one of the next topics, but what a controller is going to do, we have the access point. We have our wirelesses, and here we have different VLANs connected to it, and yes, we can label the VLANs. Each of them has a different SSID to connect to it, and the SSID then gets associated with a VLAN. When it gets to the switch, all of the traffic for a particular VLAN goes only to the ports on that VLAN, and then we go into our router. So wireless access point, VLANs on the wireless access point, SSIDs on the wireless access point. Connect at some point a wired connection to the network. So provide the wireless and can be connected, can be discovered and join a control and provisioning of wireless access points, CAPWAP controller, a wireless controller. Network interface to connect to the wired network, and an antenna or infrared receiver. Maybe infrared's very, very short distance, very, very slow. So you may or may not. Infrared remote control on a television is the more likely place to find an infrared receiver, although I think most of the new ones are actually an RF remote. Necessary to receive the wireless signal on SSID 32-bit alphanumeric string. Identifies the WAP. It's the name. It's the one that it's the thing that we see when we look at the wireless access points available. You, me, whatever we name them. My access point. So the SSID is the name of it. Security features that enable you to specify wireless devices that can make connections to your wired networks. We can have a MAC filter, a media access control, a physical address filter that says if you're not on the list, if your MAC address isn't on the list, then you can't connect to this network. We also use pre-shared keys. WPA2 is going to be the preferred protocol that we're going to use in these things. WEP, the original, is the one that we don't want. WPA, which was basically an upgrade for WEP, but it worked better, and then WPA2. WPA2 essentially is the new AES encryption protocol. So wireless MAC filter only allows devices that are on the list, the MAC address that are on the list, to connect to the access point. A couple of different ways to control access to that. The problem with the pre-shared key is how long you're going to be able to keep it a secret. Wireless controller, the Cisco Unified Wireless Networking Solution, 802.11, and that's the standard number that we're going to use for wireless networking solutions for service providers and enterprises and home as well. Cisco Wireless, okay, well, the Unified Wireless Network Solution won't do that. The standard will allow us to also do home. This is going to be more than we're going to pay, and we don't need it at home. When we have the wireless controller, if we have lots of wireless access points, if we have 2 or 3, you go and make the modifications. What the wireless controller does, let's say we have 100 wireless access points. We have a large warehouse, and we need to have the fork driver stay in continuous contact. So we have 100 wireless access points that maintain continuity across this large building or even a campus. And we want to change something, a policy or whatever, on the wireless access points. We could either go to 100 of them, or we can allow them to be managed by the wireless controller. And in order to be able to be managed by the wireless controller, they have to be a lightweight access point. Interestingly enough, you buy a Cisco wireless access point. It is one that you would log in with your web interface in order to do that. And if you're going to do a Cisco one, trust me, it's better if you do it with the web interface. From the command line, it's a lot different than if we were managing the command line for a switch or a router, which we'll do in the course. But we upgrade the heavy access points to a lightweight access point, and then we can manage it with a wireless controller. Once you upgrade it, you have to use the wireless controller to manage the device. And what this is showing down here, we have the active wireless LAN controller, goes to a switch, connected to a switch, connected to the different access points where we can send configuration information to all of the devices, 100, 300, 1,000, doesn't really matter, or 3. Of course, if 3, you wouldn't really do that. Consists of Cisco wireless LAN controllers, associated lightweight access points controlled by the operating system. Using the operating system user interfaces such as the web user, command line interface, and the Cisco wireless control system that we're going to do here. Simplifies deployment and management of large-scale wireless LANs. Provides a unique, best-in-class security infrastructure, and this is from a Cisco, obviously, and it really does. Configure standardized wireless policy throughout the enterprise so that we can do it one time and we are consistent, because we don't go from one to the other and say, oh, this is what I think I did on the last one. Wireless controllers, and this is kind of a repeat, devices that manage the access point configurations and firmware if we need to update it, upgrade it. Faster response to business needs, centralized management instead of going to the 100 different access points and doing it manually, and hopefully that we get them all the same. We do it one time and it gets sent to the 100 devices. Simplify the deployment operations and management of network and reduce the overall operational expense. This is like a one-time, could put the I in there, expense. Whereas if we have to hire enough people to manage this thing, then that's going to be an expense time after time after time, and that's one of the considerations. One of the things to think about in networking is that you need fewer individuals now, but you need better educated and more knowledgeable individuals to manage these things. When I first started, if we wanted to, and I may have said this already, we wanted to install Microsoft Office on 300 machines, which we did. We gave everybody that we could a CD, and we went out and said, okay, install Microsoft Office. A few years later, after Windows 2000 server, we would create a policy, and then when the computer started, it would automatically install Microsoft Office. So we went from, let's say 5 people to 1, but this 1 had to have a bigger knowledge base in order to do that. All these guys had to know how to do was to double click. This guy has to know how to write the policy, manage the policy. Provide flexibility to configure the management of the security settings at any time using the centralized provisioning, network-wide centralized security policies across the wired and the wireless network. So we get standardization with these things, and we get consistency as well as efficiencies with our individuals. This is just an image of kind of what we might see structurally with these things. We have HTTPS. This is the management station, a workstation that's going to the wireless control system, which is then going to connect on down. We got CapWAP that we're going to connect to these wireless access points. CapWAPs are going to automatically join what goes on. So all this represents is that we can have a bunch of these things. We have our devices connected to our wireless and on back up to our switches, which in this third-party server we can connect to a resource to get to the devices. A firewall, sure you're using one at home, using one at business. What the firewall does is protects us from suspicious or unsolicited incoming traffic, but allow incoming traffic sent as a response to a request from the internal host. What that means is if I'm here in my trusted network and I go out the firewall to the internet, then I'm going to have an outbound, and we're going to create what's called a state table, which says, hey, I ask for some information. When the answer comes back in, out and then comes back in, the firewall checks the state table to see if I initiated that connection. If I do, it allows the traffic back into the network. We can also permit traffic that has been specifically permitted by a system. Access control lists, if we want to allow, and here we have a DMZ. DMZ is one that allows anything to specific services, and here's going to be a web server and a mail server. So what this says is anything comes in here going to initiating a connection from outside, from the untrusted network over here, that goes to port 80 to this IP address. Yeah, let it through to get to the web server. Don't let it get to anything else on this machine, but we can filter it to allow it only to get to the port 80 to the HTTP port, at 443 the HTTPS port. So we can filter these things to allow everybody access to a small set of resources on our network. Use complex filtering algorithms that analyze incoming packets based on destination, source address, port numbers, and data type. When we get into firewall discussions in depth, we're going to find that they can look excuse me, inside the packet. Once they look inside the packet, they can make determinations of if you had like Yahoo chat and Microsoft chat. No, Microsoft has that anymore. It can distinguish between those and maybe allow Yahoo and not Microsoft, or allow AOL Instant Messenger and not anything else. Allow Facebook Messenger and deny something else. But we can look at those things. They can look to such a point that I used to do a lab in a security class where we did a DNS spoof, to where we would go in and spoof. If you type google.com, you go to Yahoo. Put in one of these high level, the headquarters did, because we had to go through them to get out, put in a high level firewall, and when we did this spoof, it would look inside the packet and say, oh no, you've made a mistake, and it would correct it for us. So they can do an awful lot for you, both going in and out. And one of the things to remember, we say filtering coming in, filtering going out can keep you from participating in bot armies. So you probably may want to look at your outgoing traffic as well as the incoming traffic. Information about incoming or outgoing connections can be saved to a log and used for networking monitoring or hardening purposes. We can do log analysis to see if somebody's trying to attack us, for instance. How many scans are there? And if you look at these logs, you're going to find that there's an awful lot of people out there trying to get in to find out if you have unprotected resources, something that they can use. So the hardware portion, we talked about hubs and repeaters with the layer ones have collisions. They are one collision domain. The switch was we had two types of switches, the layer 2 and the layer 3 switches. The layer 2 switches were at the access layer of the Cisco hierarchical model, layer 2 of the OSI model, and then layer 1 of the TCP IP model. The layer 3 switches were at the core layer of the Cisco hierarchical model, and they can either be at layer 2 or layer 3 of the OSI model. They start out in the world as actual layer 2 switches, but we can modify them with commands in order to allow them to route switch in IP address so that they can be a layer 3 device, just like a router. Switches in hardware, a router routes in software. And then firewalls prevent unwanted connections and filters. And it has filters, and I've got connections spelled wrong here. You probably noticed that, huh? Connections, unwanted connections, and filters. The access points, we had a wireless access point, and we had controllers that were used to configure the lightweight access points. So that's kind of covers the objectives, the hardware objectives of the ICNT. So we'll quit now. We're at the 25-minute point, and the next we're going to look at the Cisco 3-tier architecture. Hope to see you there.